This is the last unit that we're going to be looking at. And our goal today is I can determine the perimeter and area of regular and composite figures. So what we're dealing with here are two-dimensional shapes. Okay, and many of these shapes you've been studying for a long time in elementary school. And we're also going to be looking at composite shapes. Composite figures is the term that we use. Okay, so this is 6.1, and the first thing we're going to do is we're going to look at familiar 2D shapes. Now we're going to do some talking about them, but as far as memorizing the formulas, you do not have to memorize them. You're actually given a formula sheet that you can have obviously for your final exam, but you also get this same formula sheet for EQAO. But the important thing is to know, make sure that you read it so that you know what it stands for. The first shape we're going to look at is a rectangle. Now, I have here about a square, but we'll talk first a bit about the rectangle. Now, a rectangle has opposite sides are equal. Okay, so that's why we have the one tick. These sides are equal. And here, two ticks, these sides are equal. So opposite sides are equal, and we have the right angle. Now we know when we're talking about perimeter, perimeter is the distance around the shape. So if I had to take a string to go around the shape, and so we know that the perimeter is we have a length plus a width and a length plus a width. So one way that we write the formula, and this is the way the formula is in on the formula sheet, is 2 times everything in the bracket, so length plus width, and then add it, then multiply it by 2. We also know that its area is length times width. Okay, so again, you've worked with this before and you don't have to memorize the formulas. Now I have something here that's really important because students often are very confused about this. A square is a special rectangle, and it's special because all sides are equal. Remember I told you the definition of a rectangle was opposite sides are equal. Well, that's the same as a square. Its opposite sides are equal as well. Okay, but actually all four of them are equal. So when we're talking about, if we wanted to talk about making a formula for a square, it's very, very similar to the formula that we have here, except it's a little bit different in the sense that we know that the, for instance, the perimeter would be equal to, sorry about that, the perimeter would be equal to 2 times a side plus a side because the sides are all equal. Now, we can actually simplify this further because that's the same as 2 times, and how many s's do we have here? 2 s's. So we actually have the perimeter of a square actually equals 4s. Okay, now let's think about the area of a square. We know an area of a square is a special rectangle, length times width. So it would be a side times a side, which would be s squared. Okay, so that's just a little side note because I often know that students don't get the idea that a square is a rectangle. It's a special rectangle. Okay, the next shape, and we're going to look at the parallelogram first. Now, on a formula sheet, they will define exactly like I have here, A, B, and in this case H. Okay, so A and B might be the same length, then it would be a rhombus, or they could be very different. One thing that's really important here is our H. Our H is our height of our parallelogram. Okay, and it's a perpendicular height. Okay, so that's important when I'm looking at the formula sheet that I look to see how they have defined their letters. Okay, so now if we look at looking at the formula for a parallelogram, its perimeter is very similar to a rectangle because it's distance around. So it would equal 2 times A plus B. Now, the area of a parallelogram, because it's like a squashed rectangle, because actually a rectangle is a special parallelogram, it's a squashed rectangle. So I need to have its base times its height. Okay, so base to its height. And the B and H are important in the sense that the H goes down to the B. So I could have made an H a different way down to A if I wanted to. Okay, but then I would use A with my new perpendicular height. Okay, so it's important to look at the diagram and where they had the variables. Now a triangle, the triangle is, if you notice here, I have each of the three sides labeled A, B, and C, and I also have a perpendicular height down to the one side, and I have it down to the B side. So on my formula sheet, if I was making one, it would say perimeter equals A plus B plus C. So in other words, the distance around. My area would equal my base, my B in this case, times the height divided by 2. Okay, now sometimes you'll see the formula written like this, 1/2 B times H. They mean the same thing, and you can use either form when you're working. Now I also have here Pythagorean theorem. Now the reason I have it over here is because this is kind of a given thing in the sense that anytime you have a triangle, you always have to, and especially in obviously a right angle triangle, this always comes into play. So if you're missing some piece of information and it's a right angle triangle, you may have enough information to find the unknown that you want. Okay, so that is always in the background of your mind. Okay, the next shape that we're going to look at is a circle and then a trapezoid. Now a circle, if you notice right now I have no shape, I have no letters here, and I want to talk about that for a second. So first of all, a circle has what we call a diameter, which starts at one point on the circumference of the circle, goes through the center, and back out to the other side. So that whole distance is called d, which stands for diameter. And we have formulas that use the diameter, but we also have formulas that use half of the diameter, and we call that the radius. Now I'm just going to put my radius down here, which is, the same thing here. So this would be r. So r is half of the diameter, so radius. Now, the reason that's important is because I have two different formulas for the perimeter of the circle. Now the perimeter of the circle is also the same as what we call the C of the circle, which is the circumference. So the circle gets some special treatment in a sense. And it equals pi, and we're going to talk about what pi is in a second, pi d, or, and I don't like it this quite, my pen quite this thick, or it's equal to 2 pi r. Because remember I told you up here that the radius is 2 diameters. So if I know the radius, I just change the formula so it says 2 times pi r. And I have the area is equal to pi r squared. Now, this pi is actually a Greek letter. Okay, and we use it as a number, which is approximately 3.14. Okay, so it is actually bigger than that, 3.14, because the decimal goes on forever and ever. It's one of those irrational numbers. Okay, and what we do is scientific calculators actually have a pi button on them. So you should look at your calculator to see where your pi button is. Okay, so you have a pi button. If you don't have it, or if you can't find it, then you would use 3.14 in your calculations. The next shape that we're going to look at is the trapezoid. Okay, again, watch how they've labeled things. A trapezoid has only opposite sides that are parallel to each other. And again, we have a perpendicular down. And there's really no problem as far as doing the perimeter because perimeter is the distance around. So perimeter would equal A plus B plus C plus D. Now the area of a trapezoid equals, and it's a little bit funny one, they take A and they add it to B. So they take the top and bottom, they add them together, multiply it by the perpendicular height, and then divide it by 2. Okay, so again, you don't have to memorize these, but it's important to see how they have labeled, how they have labeled the variables on their diagrams. Okay, so the next thing we're going to talk about is composite shapes, and then I'm going to pause and then we're going to do the examples. So a composite shape is just a shape containing two or more two-dimensional or three-dimensional shapes. Okay, so we call it a composite shape, we call it a composite object, especially if we're in 3D. Now, the strategies for finding the area, because that's usually the hardest part, area, is you break it into shapes that you know. Okay, and if I look at this one, I can see that I have part of a circle, it looks like I have a triangle, and it looks like I have a rectangle. Okay, I know those shapes, so that's what I would do. Okay, and what I would do is I would label my diagram, and then I calculate the area for each of those shapes. Okay, it's that simple. Okay, so I'm going to pause it and then we're going to look at, I have, I guess, 3 different examples in this section. So it's not too bad, I do not believe. Another thing that I have here that I just remembered, remember that perimeter is the distance around a shape. Note the dotted lines. Okay, so for instance, if I was doing this shape, I maybe divide it up in order to calculate the area, right? Because there's my triangle, there's my rectangle. So I cannot use the formulas for the whole triangle because I'm only using 2 sides. I can't use the whole formula for the perimeter of a rectangle because I'm only using these 2 sides for my shape. Okay, so just be careful of that.